Login accepted.
All right, let's get started, everyone. I'm just going to quickly introduce myself. I'm Kirti Shriram, and I'm a member of the Google Developer Group's chapter on campus at Cal Poly Pomona. If you're interested, go and join. Today, we're going to talk about securing cloud infrastructure using Google Kubernetes Engine. It's mostly about securing applications on the cloud, which we see a lot nowadays, right? A lot of applications are being containerized on the cloud and not just locally. Before that, how do we like the weather today? Do we like the rain or not? Yes or
the
no?
rain is nice.
Yeah, all right.
I'm a good weather.
Yeah. All right, let's get started with our workshop. Can you?
Yeah.
All right, before we move forward, I just want to introduce our program, which is the System Design Study Group at Google Developer Groups. We're studying every Thursday from 12 to 1 p.m. in the library about system design concepts. It'll be really helpful if you're into software engineering, and it teaches you how to design systems at a scale. You know, applications like Netflix, Instagram, Facebook, and all these big ones. How do we operate these at a bigger scale and make sure they don't break? Right. So that's all system design is about, and making smart choices when you're building applications. So if you're interested in that aspect of software engineering, definitely join our study groups. They're really helpful and more close because there's it's in the library and it's just chill. We just talk to each other and learn. But yeah.
And then for some fast announcements, if you guys haven't already, or if you guys are new to the club and want to know more about what we do as a club, feel free to join our Discord, check out our socials on Linktree, and connect with us. Next week we will be having our resume workshop with Dr. Dan Madsen, and he'll be reviewing you guys' resumes. That'll be next Thursday from 12 to 1 p.m. Molly.
Okay, and then we have Tech Symposium. I'm with Swift, clearly. And this is an event with networking professionals with free food. We have our event on March 14th, 10 to 5 p.m., so it's coming up. Make sure to RSVP. We're going to have a lot of free tech giveaways and hands-on demos from our partner universities, and we're really excited to host this event for you guys to learn more about cybersecurity. Yeah, so we have all three of our clubs all coming together to put on this workshop.
Hope you guys are excited. You're gonna do a lot of hands-on stuff today with other people, so get ready. If your laptop's not charged, get it ready because it'll be useful in a while. But yeah, today's agenda. What are we gonna do today? First, we're gonna learn about some security concepts related to securing cloud infrastructure, right? What it is, why we should secure it, and what are some general good principles to use when we're securing cloud applications. And then we're gonna set up a Google-related lab, and we're gonna work with Kubernetes Engine. And then we're gonna actually do the lab with other people in this room. So yeah. Okay, so let's get into the actual concept part. What is securing cloud native infrastructure on Google Cloud? Anyone here knows about cloud applications, what it is in general? What does it mean when you host an application on cloud?
Takers and guesses are good as well.
Guesses. Winners get a gift, which is a handshake with me.
Isn't it just like an application store with server that's accessible through the internet?
Yeah, that's pretty much it. AWS is a good example. Google Cloud, if you've heard of that, which we're going to talk about right now. Any other descriptions or answers? Okay, we're gonna move forward. So he's right. So it's basically running containerized applications on the cloud so that the data is accessible from anywhere, like when you use AWS or cloud stuff like that. So modern applications run on containerized infrastructure, and cloud environments introduce new security risks. So whenever there's a technology, there's a security risk for that, right? Do we all agree with that? Whether it's AI or whether it's just local application or whether it's on cloud. So whenever there's a new technology, there's a security threat there or a vulnerability if you don't handle it right. So misconfigured permissions are one of the main causes in cloud to cause security breaches. When people that don't need access are given access to cloud servers and data, that causes a huge problem and security risk, which we're going to target today. So yeah, I mean, secure design requires both identity and network control. So we're going to learn more about this. So a really good principle, not only in cloud, but in general, is the principle of least privilege. Whenever you're assigning roles or users to different members of an organization, every identity should have only the minimum permissions necessary to do its job. It's like a Newton's law. It's like really important. Like a person should have the least amount of privilege to access a system, is what we're trying to say here. Nothing extra, no extra database permissions or access. So instead of giving like a cluster or a group of users editor or owner access, you can create a dedicated service account or attach only the required roles that they need, or create custom roles for storage permissions. And the lab today that we're going to try is exactly that. You're going to create a Kubernetes cluster on Google Cloud and create service account users and general people users and assign roles to them, so that you secure your cluster on Google Cloud. So basically, if you didn't get any of that, in a simple way, you're going to learn how to make sure people don't have too many permissions when they're operating on Google Cloud. Does that sound good? Yeah? Okay. All right, service accounts. I mentioned that word before. What does that mean? So you have an account on Facebook. So that's a user account. You have an account on Instagram. That's a user account. What are service accounts though? When there's different machines operating for different purposes, like running AI models, or some machines could be in charge of, I don't know, hosting different websites, or some machines can be in charge of storing all the data, like servers, right? So service accounts, what they do is they're like an identity for those machines, not real people. So just like how I have an Instagram account, service accounts, machines have service accounts in the environment. Does that sound good? Yes. So instead of running as a default computer engine account, instead of just like making it a vague thing, we assign those machines actual roles so that when we audit or when we have breaches, it becomes easier to identify where it went wrong, which machine it went wrong, so that they already have accounts, right? So it becomes easier to troubleshoot and see where the problem came from. Quick introduction to Kubernetes. It's basically an open source system that helps in automating the deployment, management, and scaling of applications. So it's used to kind of store and scale like applications, which are bunched together. That makes sense.
Fun fact, it was also developed first by Google.
So what is a private Kubernetes cluster? So quick background about Kubernetes. They often have, like the clusters often have public control planes. So anyone from the internet can access the endpoints kind of. And that means that the Kubernetes API server is reachable from the internet, which it should ring a bell by now. It's really a security threat. So a private cluster, what that does is it makes sure worker nodes only have private IPs. So like the ones I said before, like service accounts, there's worker nodes that have private IPs that handle certain applications within the website. And access is restricted by internal networking, meaning only the admins can assign roles and give permissions to certain service accounts.
Okay, so even inside your virtual private cloud or the kind of environment that you create on AWS or Google Cloud, not everyone should be able to manage a cluster. We should be able to separate users and administrators and maintainers. So you configure only specific, one of the things you can do is configure only specific IP addresses or devices to be able to access the management controls. And in this lab, we're going to be doing that with the jump host IP address. The jump host IP address is essentially the access point where we're able to control our Google Cloud infrastructure. So that means if somebody spins up another VM inside the virtual private cloud, they're not able to access the management infrastructure. They're only able to access it through our jump host IP address.
Quick question to see if y'all are paying attention. What are service accounts?
I started.
For the system.
Okay.
Essentially, yes.
And what are we doing in this lab that we're gonna do in like a couple minutes?
Or the cloud.
Yes, perfect. All right, let's go on.
And so one of the methods we can use to kind of help our security of our infrastructure is creating creating custom IAM controls. IAM stands for Identity Access Management. So this is essentially creating accounts or service accounts. So built-in roles for a lot of these cloud providers like AWS, Google Cloud, they often are too broad. Two of the default ones are like user and administrator, where the user will have like the lowest level of control and administrator will have the highest amount of control. And really, like we explained earlier with the privilege of least access, we don't want any role to have all the permissions, right? And that's having all the permissions isn't necessary for a lot of the day-to-day maintenance and usage of that infrastructure. So with custom IAM controls, you're able to more finely define what your user accounts can do. And so once we've kind of deployed our infrastructure, how can we test or how can we make sure that our configurations are validated? How can we make sure that we're able to do what we need to do on our VPC? Well, we can do a couple of things, kind of like a checklist here, but this is not a very definitive list. What you can do is just SSH into the jump host, make sure you're able to actually control or go onto the jump host to have access onto the management controls. And then you can just retrieve the credentials with your internal IP address. This makes sure that your networking is correct. And you can just deploy a really simple application like Nginx, a web server, just to make sure that your app is able to deploy onto the VPC. And what these steps kind of do just confirms that the cluster that you created works, that your IAM controls are also working, and that your networking and Kubernetes control functions fine. Yeah. So with that being said, we'll get started with setting up in the lab.
All right. For a second, I want y'all to think that you're Google employees, okay? You're serious high-level Google engineers in the security department. You're at like the top L4 level stack. Y'all are like goated security engineers from Google. All right, so I'm just gonna give a quick overview of what we're gonna do in the lab. So there's like a challenge scenario for today, right? You started as I'm just gonna read it out loud, so follow through. You have started a new role as a junior member of the security team for the Okra team in Julie Incorporation. Your team is responsible for ensuring the security of the cloud infrastructure and services that the company applications depend on. You're expected to have the skills and knowledge for these tasks, which you went through, and you will deploy, configure, and test a new Kubernetes engine cluster so that no users have more permission than required. And the Kubernetes cluster is private and secure. So you're setting up a secure environment for the company, Okra. In order to access this, please follow these steps. Are the slides available to everyone? Yeah? Okay. Go ahead and go to slide 16, follow through the steps, go to Google Cloud Innovators. You should get 35 free credits every month to try out Google workshops or even use them for your personal use. That's a good resource by Google. 35 free credits, just use them. But yeah, please raise your hand and let me know if you are having any problem accessing the credits and we can come and help you.
little heads up that anyone can actually edit this slide.
Oh,
Yeah, don't edit the slides, guys. What do you get from doing it, huh?
good flag we can give for prizes. There you go. We just
Okay.
demonstrated the principle.
Yes, principle of least privilege, guys. Don't give edit access to everyone like me.
So once you guys have already created or joined the Google Cloud Innovators group and then gotten your free 35 credits, go ahead and go on to step 3, where you're going to be able to actually access the lab itself, deploy the machine. We'll have to start doing groups now, right?
Make sure people are.
Oh, okay.
done with
Okay.
support.
Yeah. So currently we're just making sure everybody is able to get on Google Skills and get those free 35 credits to actually deploy the lab. Let us know if you guys have any trouble with that, and we'll go around the room and just help you out.
Everyone got their 35 credits? Hands up if yes. No.
Okay, so just to show everybody in the room, where you want to go after you went to this link, the innovators page, it should take you to this sort of dashboard. And what you guys do next is just click on the View Benefits button. If that's load, and then it should be this one. So you want to click on this Try Now button that's under monthly Google Skills credits. And so you'll get free 35 credits per month that we'll utilize for this workshop. It's going to take you to the Google Skills page, and then through this page, just join in. Or we've already done it, so it's not going to ask us. But I believe after you've logged in, it'll give you guys the free 35 credits. Let me guys. Yep. All right, guys. So the actual kind of link you want to click on is this gear link. That's going to take you to the actual program that you have to join as a member to get to the 5 credits. Sorry, so it's actually this page right here. Is it? Okay, yeah, it's just weird. Like everybody has like a different like status for your accounts. So if the steps that we explained earlier doesn't work, go through this step right here. All right, so once you guys have already gotten the 35 credits and then are able to deploy the lab, every row that you're sitting at, that whole table group, is your working group. But for those who don't have a working laptop in a row, you guys could move over, try to find somebody. We'll find you a person have you work on the lab with. So
Each row is a group, and y'all are working together to solve the challenge. Okay.
It's actually.
No, it shouldn't ask you for card information. Don't pay anything at all. Don't get.
What about like have you done like
Alright, guys, this challenge is to successfully deploy the Kubernetes cluster. And whoever does it first wins Swift Club merch and a free Google t-shirt. So work with your group in your row and make sure it gets done. And yeah. Okay, so click notice. Quick notice, please. Everyone, listen to me. If you have credits, find someone that don't and work with them, because that's really nice and kind of you and demure of you. So if you're at this page and you have credits, go ahead and click on start. No. Click on Start Lab. And then launch with 5 credits. It should cost you 5 credits to do the lab. If you need a clue on if you're ever stuck in any of the steps and need clues on how to do it, you can refer to the guide on this slide. It'll have clues. So consider this a CTF. Whoever finishes it first gets a prize, and the clues are in this guide. If you want. Is everyone at this point of the lab? In order to go into an incognito browser, this is how you do it. Right click on Google Cloud Console, and you know how it says open link in incognito window? Open that, and then it'll take you to an incognito window. And then click I understand, even though you don't. And then you should be in the Google Cloud Console.
Yeah.
And then agree. And then if you're wondering where the console is, it's on the top right corner where it says activate Cloud Shell. Click on that button, and then it'll take you to the Cloud Shell. From there, you can start your challenge and do everything. Authorize, trust.
But sorry for those on Zoom who aren't able to get onto the lab itself. Let me go ahead and address your questions just one by one here. So I think we were able, if you guys aren't able to on the Zoom access the lab, please let us know. Oh, okay. So Ethan N was actually able to get the tokens by clicking on purchase credits and getting the free plan. That works too. But like we demonstrated or like we showed, you should be able to also get it just by signing up through the gear program on the benefits page on the Cloud Innovators link that we linked in the presentation. Thank you guys so much on Zoom or in the chat for helping each other out. Quick check though, is everybody on the Zoom able to get to the lab and start it up? Please let us know. Okay, Ethan, you're good? Okay.
Hey, I know some of you have to go. You can always complete this after going home. But I just wanted to let you know that this lab is a part of a certification from Google called Implement Google Security Fundamentals. So if you click on that, you can get access to course content and other labs which you can finish to get a badge and show off on your resume.